Okay, so we're trying something new. I have it set up now where I can be taking notes and you guys can actually see me. So, we are going to be graphing tangent and cotangent. So sine and cosine had a period of 2 pi. Now tangent actually has half of that. So part of the reason this is, for sine and cosine it takes a full revolution around the circle for you to get back to where you started. But for tangent, you may remember that we were talking about how tangent is actually the slope at any one of those points. So on the left side, the angles have the same slope as on the right side. And so for tangent, we only have that right there. Because if you flip it over, you're going to have the same slopes on the other side. And so one important thing about tangent is that the period is going to be pi. It's the same for cotangent as well, because cotangent is the reciprocal of tangent. So first of all, let's talk about what does the tangent parent function look like. So we're just going to graph the normal tangent of x. So we already said that the period is going to be pi. So you may remember tangent of 0 is 0. And then when you get to the top of the circle here, as you travel up to the very top here, tangent right there is undefined, which means there is actually a vertical asymptote there at pi over 2. So down here, we're going to have pi over 2 marked here, and that's going to be a vertical asymptote. So going in the other direction, if you look down at the bottom, negative pi over 2, you're going to have another one. Okay. And this is going to repeat again, because if we go further around the circle, and say we go all the way over to 3 pi over 2. So imagine you're traveling around the circle going this way. You're going to hit an undefined point there, but then if you go another pi still, you're going to hit another undefined point at the bottom. And so that is going to be what I'm drawing here, this undefined here. And so when we draw these, we want to include at least 2 periods of tangent and cotangent. And when we do secant and cosecant later, we're probably going to include 2 periods as well. So, as we were saying, at 0, tangent is 0. Also at pi, tangent is 0. Okay? And then if we go around our unit circle, if we go up exactly pi over 4 right there, that's going to be a slope of 1. So pi over 4 is exactly halfway between the asymptote and 0, and we are going to be up at 1. We can also include this. Now, that's not quite to scale, but that's fine. Okay. So we're going to, if we were to put the other points there, what we would see is that it curves up like this. It's kind of like a cubic, but not really, because it's hitting a wall on the left and the right sides. So same thing here. If we went to halfway between pi and 3 pi over 2, that would be 5 pi over 2. So that would be 1. And then back here would be, what's halfway between pi over 2? That would be 3 pi over 2. Over 4, sorry. These should be all over 4. So I have some of these critical points here, and that's 2 periods of just a normal tangent. It's going to repeat over and over and over. And the width of these dotted lines is just pi every single time. So now what we're going to do is we're going to start stretching the period. We're going to start stretching the amplitude, and we're going to start shifting and moving these things around. One of the things here, though, is you might be wondering, what's the amplitude here? For a sine and a cosine wave, it is the distance above and below here, and that's called your A. But here, we don't really have a height or max. So what you're focusing on is on those key 1 and -1 points when you're doing your amplitudes. Okay, so let's do our first example here. So we're going to do 3 tangent of x over 2 minus pi over 4. Okay, the first thing you always do is factor out something inside of the tangent. This is just like sine and cosine. So we're actually going to rewrite it as 3 tan, and the common factor here would be 1/2. So we have x minus, and then I like thinking if I was to multiply the 1/2 back in, how would I get pi over 4? So this would have to be pi over 2 for that. Okay, the next thing that I would do is figure out the period. So in this case, for tangent and cotangent, the period is going to be pi over b. For sine and cosine, it was 2 pi over b, but here it's just pi because the period is normally pi. So in this case, the period is going to be pi over b, the number that's in front. So remember, that is a horizontal stretch. When it's smaller than 1, it's going to make things longer. The period expands. When it's larger than 1, it's going to contract the period. And that's because inside your stretches, your horizontal stretches, it's always going to be opposite of what you think. Okay, so if I put 1/2 down here, this is going to be a period of 2 pi. So normally it's pi, this is going to be every 2 pi. The other thing that I'm going to focus on is where is it going to be shifted. This means right pi over 2. Okay, and what I'm shifting there is actually my center. So the tangent used to be at 0, 0, but now the center is going to be at pi over 2. So that's my 0, and then my period is 2 pi. So because it's 2 pi, that means we're going to be going, think about it as pi in both directions. So if you go back here, the period was pi, so you are going kind of pi halves this way, and you're going pi halves this way. And I think that's the easiest way to think about your period here. So from here, we're going to have to go a pi forward and a pi backwards. If I go a pi forward, I'm going to be hitting my asymptote, and pi over 2 plus pi is going to be, that's going to be 3 pi over 2. So we'll write that there. Pi over 2 minus pi is going to be negative pi over 2. Okay. And we have to start marking halfway points. So halfway between pi over 2 and negative pi over 2 is going to be basically 0. What's halfway between pi over 2 and 3 pi over 2? That is 2 pi over 2, which is just pi. And so at these points, these are where we would normally put 1 above and 1 below. Normally it would just be 1 there and 1 there. But we need to be careful because there is a vertical stretch. This 3 up here means that we're going to stretch everything by 3 vertically. So instead of 1, if we go over to pi, it should be 3 times taller up here. And if we go over to 0, it should be 3 times taller in the opposite direction. So we should have a longer, more stretched out version of tangent. That's not the prettiest picture, but we get the idea across. And so that would be covering everything that we needed to do. Always focus on your period first, and then move your center. Then worry about filling in your dots. We also want to include another period, so we're going to keep running this over. 3 pi over 2, if we add a pi to that, would be 5 pi over 2. Right? 3 pi over 2 plus a pi would just be 2 pi over 2, so that would be 5 pi over 2. Okay, halfway between those would be 4 pi over 2, which is, 8 pi over 2 divided by 2, so that would be, why am I having such a hard time with this? Okay, so I paused the video to think, and I realized my error. Our period is 2 pi. And so we want to make sure that we are going 2 pi between. This should be 2 pi. So actually this should be 4 pi over 2, which is 7 pi over 2. That's why the math wasn't working out. Alright, so halfway between, if I just average these, it would be 10 pi over 2, which is 5 pi over 2. And at the halfway points, we would have 3 and negative 3. So we're going to see a long stretched out tangent. It's kind of hard to draw the curves with this kind of scale. Okay, so when you draw these, you should be including 2 periods. We are going to now go on to the cotangent and just talk about the difference. Cotangent will have the same period, so you still do pi divided by b. But tangent will start at a different spot. Remember on the unit circle, if this is 0 for tangent, it's actually undefined for cotangent. So, instead of being centered at 0, it's actually going to be undefined at 0, and then it's going to be undefined over here at pi. So if this is pi, we would have another undefined point. That means the center point, the 0, is going to be at pi over 2. Okay, the other thing is that cotangent, that's 1, but it's going to be the reciprocal. Okay, so if I was to write out 3 points here, normally tangent is root 3 over 3, it'd be 1, and it would be root 3. But it's cotangent, so it'd be the reciprocal. And so coming from the other side, we would be going from root 3 to 1 to root 3 over 3, and then downwards. So what I'm saying is that the key point 1 now is actually going to be on the other side of where we had it before. So it's like a negative x cubed. Okay, and if we were to repeat this, this would go over to 2 pi. That's our vertical asymptotes. And then we would have something like this again. So it's going to be basically the same. The thing you need to remember is that these key points are switched around. And the period is the same, but it's centered around a new point. The centering point here is pi over 2. Alright, so one thing to point out here. You can take tangent and shift it so that it is the cotangent graph. So let's draw a quick tangent here. Normally, tangent will look like this, between negative pi over 2 and pi over 2. If we want to shift it over so that it looks like the cotangent graph, it's actually not that hard to do. So we're going to have dotted lines here and dotted lines here. The center is going to be shifting over to where the old asymptote was. Okay? And instead of having a tangent run up like this, we want it to be flipped over. So what we would actually do is make it negative and flip it vertically. So tangent of x and cotangent of x are related in this way. If you take tangent, you make it negative, and you shift it over by pi over 2, it's actually going to be the same as cotangent. And so that's just a visual proof of something called a trig identity. We're going to do that more after this chapter 4 test. But if a question asks, how do I get tangent to be shifted over and equal cotangent, you should be able to visualize these two and then put in the flip or the horizontal movement.